Adam Savage here in my cave with a one-day build that took so many more days than one day. This is the fruits of my labor. It has already happened. I'm introducing this video from the future. And this is, if you don't already know, this is Hellboy's sidearm, the Samaritan. One of the most beautiful cinema weapons ever designed, built for Guillermo del Toro's first and second Hellboy films. And this is a gun I've been obsessed with forever. I've actually held one of the originals that's in Guillermo's collection, and I wanted to make one when I touched the original, but I have never felt that I was a good enough machinist to bring something like this into being. But a couple things happened this year. One was COVID and the lockdown and my diving into my mill and my lathe and the precision that I've been learning that I can bring to bear on these builds. The other thing that happened is that Grant Imahara died. And it threw all of us, me included. And I felt after he passed that I needed something like a big, deep build to sink my teeth into. And this fit the bill. I decided to go all the way inside this thing. There's well over 100 hours of my labor. And to be clear, I started out with chunks of aluminum like this and like this. And made a lot of mistakes along the way. I filmed most of it. Some of it's off camera, most of it's on. And over the next few weeks, we're going to be releasing videos of this build. And I'm going to be continuing to finish this, right? It's not black, it mechanically doesn't work. All that's still going to happen. And we're going to walk you through the entire process. Let's get started. Well, work on the Samaritan proceeds apace. You can see that I've got every model I've ever possessed of the Samaritan here in front of me. I believe these are the two sideshow Samaritans. This one is zinc-based metal. This one is plastic. Both are legitimately cast off. No, they're not cast off the original, but they share many features. The resin one from Sideshow shares a couple of really specific tells. This is an actual stunt pistol from the movie, made by Weta Workshop, from the original Hellboy film. This one is cast in hard rubber. It's cast off the master, machined by Dominic Taylor at Weta all those years ago. So I have the best reference. And the next part that I'm going to be working on is this part, is drilling out the barrel. Now, this is 7.5 inches long. And there's a thing you might not know about drill bits, which is that while a drill bit may look to you and me like a solid piece of unbending metal, the fact is that the tips of these things can move. They can wander just a little bit. And you have to accommodate for that possibility when you're drilling really long holes. The trick is you have to expect the wandering. So I have a specific aesthetic need in which I need the rear hole and the front hole to be exactly in the center of where they are, right? The front hole, if that's not centered, then I haven't done my job. I'd have to remake this piece. If the back hole isn't perfectly centered, well, then the cylinder won't fit perfectly centered behind it, and there'll be all these sort of knockdown effects. So what I am going to do, because I need this hole to be 800 thousandths, yeah, give or take, about a 0.8 hole, 800 thousandths. I'm going to drill it from both ends, and I'm going to start drilling it with a 1/2 inch drill bit from both ends. I'm going to drill very slowly. I'm going to use my mill, and I've done a couple of tests, even with, okay, actually, let me start at the beginning. I did a test with this bit right here, this super long bit that I put in my mill, and I drilled out this piece of metal all the way through just to see how I would do. And what I found was the hole was only 4 or 5 thou off at the other end, but that's enough to see visually. So I didn't want to take the risk of doing 7 inches and have it come out the other side just wrong. So this is all a game of like micro increments. I need to mount this thing perfectly square in my mill. I'm going to use this vise here to do it. I'm going to be checking and rechecking my measurements. I'm going to be using the DRO on the mill. All the little techniques I know to get something perfectly accurate. I'm going to use them with the goal of starting with a 1/2-inch drill, reaming out 1/2 inch so I have a pretty consistent hole. And then once I have that, I'm going to start slowly stepping up and literally just bit by bit. I'm not going to go from 1/2 inch to 5/8. I'm going to go all the 30-second increments all the way through, because the less material I'm pulling off each time, the more consistent my hole will be. And all of this is because it's hard to drill big, long holes. I have my barrels set up for the first drill. I'll be drilling from the front end first. I've done a bunch of things. I have checked to see that my vise is square. I used a stone to make sure that my vise had no burrs. Then I used a stone to make sure my table had no burrs. I laid my vise on the table in multiple orientations and measured its squareness with a square I know to be really precise. Then I checked the square on my barrel to make sure that I wasn't taking it for granted. I clamped the barrel into the vise and made sure that they were parallel. Then I laid my vise down on the table with enough room so that I could use a big square to make sure that the vise was perfectly square to the table. I'm not using my marks for these hole drilling. I'm literally going to use an edge finder, and I'm going to split the half between the sides, and the barrel, the hole is exactly centered 0.7 inches from the top of the barrel. It's not centered top and bottom. I'll be following that for both drillings of the hole, but it's crucial that every dimension I'm working with is as square as I can make it. So I'll actually probably be using an indicator to make sure I've got a perfect squareness on the mill here. If I'm out by even 2 or 3 thou, look, on stuff like this, every thousandth matters. And I've become a real lover of the clamping equipment on the bed of the mill over the past few months. It's afforded me much better security, and I've ruined a lot less parts with it. So I'm going to raise the table and use an indicator, make sure I'm square, and then I'm going to probably use this big 1/2 inch drill bit to go about halfway down. Then I'll flip this over and do the same thing again. The first half of the hole is drilled from the front. I am pleased with the placement. It looks like it's dead on the money. I am now going to, without removing the clamping setup, undo the vise, turn this around, retram it to the center that I want, and do the same thing from the other side. I expect when the drill bit breaks through, we'll see a little bit of misalignment on the barrel, and I'll show that to you, but I hope to correct that misalignment by slowly working through, starting with this big bad boy. That should help even out. I've also got some reamers and some other tricks up my sleeve. I guess if I really had to, I could go get a honer, but I don't think I'll need one. Here we go. I've successfully drilled the other half of the hole. It's time to take a look through the center and see how I feel about the results. I have soft jaws on the vise, so I didn't damage the barrel. I mean, that's funny, right? Because I'm going to beat the hell out of this with a hammer. All right, here's the moment of truth. Dude. Yeah, I'm actually going to say, let's see, where is the camera? There it is. I'm going to say that looks pretty darn good. I'm provisionally pleased with that. Okay, so what are the next steps? I think the next step is, in fact, to use the backstop of this vise as a constant positioner, because I'm going to want to drill a whole bunch of drill bits through this, kind of. It's going to be a lot of topsy-turvy, and I'm going to creep up on this because I don't want to screw it up at all. I've already got like 6 or 7 hours in this one piece, and I don't want to make it again. You wouldn't either. So I'm going to just go slowly. That's what I'm doing. I'm really pleased with the concentricity, with the alignment here. I'm really pleased with it. Hang on just a sec. Okay, so here is a really nice, presumably super straight 1/2-inch rod, and it just breezes through this. That tells me that there's no significant misalignment. I mean, there's about 3 thou of play in there, which you can expect from any drill bit. Normally, a 1/2-inch drill bit will drill up about 3/1000ths over. But no, I can't fault that. That's really good. So, next step, yes. Basically work out a consistent repositioning system so that I can creep this hole up to the point for the 800,000ths it needs to be. I'm at a very interesting part of the build where I've got to make some key choices. And what informs those choices is interesting. So I thought I'd talk about it. One of the things about Hellboy's gun is that it breaks. And by that I mean when you push on this lever on the real one, it hinges right. I can't do this with two hands, but it hinges right here so that Hellboy can load it. But it doesn't hinge all the way. In fact, if you look really closely here, you can see right here, there's a stop. Now the question is, how do I put that stop in my piece? And that's the hinge point of this whole gun. So the first thing I considered was, given that it's the hinge point of the gun and it's going to be a place that gets a lot of wear, and the screws that hold that hinge point screw into that piece, I decided to make it out of steel. So I turned a piece of steel down until it just perfectly fit that. Now I'm going to install that into the front barrel of the gun part here. That I've determined. But how do I make the stop? I have determined further that I'm going to mill a slot in this and sock this piece in there, silver solder it in place, and it'll be like grabbed on all three sides. It'll be really, really solid, and then lathe it to the round profile of this guy. Yeah, it is round. And then it can stop against the rest of the gun. And because it's steel, it's not going to wear out. That's my goal, right? So, oh, wow, milling out that metal part's going to be interesting. Anyway, yeah, there's some further decisions to be made. But right now what I'm going to do is chuck this into the lathe, mill a slot out. You'll see it'll all become clear as I do it, but it's all with a goal towards taking a part that is going to be a part with a fair bit of mechanical pressure on it, and making it out of steel so it can withstand that pressure. And also, I could probably silver solder a plate on there and then sand it smooth, but again, whenever I make a prop, I'm looking for an experience, and I want this Samaritan that I build to feel like it was manufactured. So I've been tumbling the parts so they have really, really uniform finishes, and I've been working in every way towards making this just not feel handmade at all. In fact, I've gone a little bit more bold with the straight knurling on this tube than the original one, which you can see is a little bit more subdued. But that is part of the experience I'm looking for when I finally hold on to this thing. All right, to the milling machine, boy wonder. Here is my center pivot with a notch carved out of it that perfectly fits this piece that is 0.475 inches wide. And that is the exact length of the stop on the Hero Samaritan, the stud Samaritan. So what I'm going to do is I'm going to silver solder this in place, trim it, take it onto the sander and kind of do a rough trim, and then take it onto the lathe and do the final cut and polish, including drilling and tapping the center hole for this. Then I got to install it, and yeah. Then I got to install it in this piece, and that's a whole nother bit of engineering. Yeah, we'll get to that. Checking in, checking in. We are doing really, really great. This is the front part of the gun. I've got some really nice tolerances going on here. This piece here is really nicely anchored. Everything is, can I describe the sheer pleasure of working at this level of scale and accuracy? It's cool. I'm having the time. You know what I mean. But it's time to move on, now that I've done most of the front part, to this part. Specifically the top part. The wooden grip is the last thing I'll make. But this top back section, if you thought this hunk of aluminum that made the top barrel and the back of the bottom barrel was big, the one that I got to make this one out of is even bigger. And I just had it on my mill. Here it is. This is this big, giant 1.5 inch thick block that I had to mill to 1.32 inches, the width of the Hellboy Samaritan. And if you can see here, I want to just tell you that that is super smooth. And it wasn't when I first cut it. No. I was using this 6 insert fly cutter, and I had a step of a couple of thousandths, and I trammed in this mill just a few months ago, and I realized I had to tram it in again. This is a non-trivial operation to tram the mill in front to back. It's slightly counterintuitive, and I did it, and I still got a step. And I realized I'd done it to the bed, the mill, this platform on the mill, but I hadn't done it to the vise. And I was unwilling to pull the vise off, so I retrammed it to the vise. I know, I'm kicking that can down the hill right now. But the vise is now trammed beautifully to the mill. It is perfectly vertical. I'm getting zeroing out on all 4 axes. It's just really nice. And like when you, when you go and you make something and you can't feel the separations between the passes, it's a good feeling. So I'm about to take this out, deburr it, and start to lay out how to cut out that next piece. So it's time to talk about some layout. Well, not talk about it, but I think a time lapse. Then we'll talk about it. Side note, I know that what you do with my milling machine is make things super precise, but working at this scale, I must say, it's a substantively different kind of operation, and maybe it's just mental, but here's something that pleases me greatly. This is my block. There it is. I wanted it to be 1.32 inches. Watch this. Wait. There we go. 1.32 inches. Yeah. That just makes me happy. I could have been off by a couple thou. No one would have noticed, but I would have known.
I'm trying not to start every piece of camera with okay, because I noticed it seems tedious to me when I watch the videos. But I'm about to do something fairly radical. I need now to, let's see, do I have parts that show this? Well, yeah, I do. Here we go. I need now to machine this round so that it fits inside this round exactly. Can't use a boring bar. It's like I have to mill 3/4 of the way around something. So how do you do that? Well, I can chuck this into a rotary table, but that's not the preferred solution. No, the preferred solution, astonishingly, is what I've got set up here on the lathe, on the mill, actually. There you can see the circle, the rough idea of the circle I want to mill. Now, what I'm going to do here is I'm actually going to start this milling bit up and start to actually move the piece physically around. I've made a pivot, I've cut it off, and I'm physically moving this in order to do this milling. Yeah, it's this is tricky, and I may have to reset this a little bit just to get it working, and I got to hold on to it with real tight hands. I'm going to wear gloves for this operation. I am using a thin bit so that I'm not putting too much torsion from the quill onto my piece. Yeah, there's a lot going on in this cut, and I'm just going to approach it kind of gingerly. We are proceeding apace, and we currently have this amount of barrel done on the Samaritan. I'm really pleased with how it's turning out. I have the laser pointer. Yes, that goes under there. And there is a rail that travels the full distance between those two things. And this rail it's a little bit of like T-track. And it is actually the exact same rail that ends up being the front sight. So I am going to make a bunch of that rail. And I have cut off this chunk of about 410 thousandths thick of aluminum. And I'm going to flatten it. And then I am going to start shaping it into the rail. I'm making more rail than I need. Because if I make exactly as much as I need, well, I'm going to make a mistake, and then I'll have to remake something. So I'm making more than I need. That sound you hear, that sound is actually my tumbler, and it is tumbling a part. But we'll get into the tumbler a little later. But suffice to say that some of these parts that it can fit in my tumbler, I am actually tumbling in ceramic media, and it's giving them this like incredible finish. This is a technology I haven't utilized in my machine builds yet. So it's pretty exciting to start seeing the results of what things look like. Here's a laser pointer also. It's like, it looks like a manufactured thing. That's what gets exciting about it. Okay, so the rails. Now the first step with I'm really sorry about that noise. It's just going to be there. Got to do several things at once. So the first thing I want to do with this rail, like I said, is flatten it out. I know I've got a perfectly straight edge on the machine edge of the stock that I had. And I am going to chuck this into the vise. Okay, now I'm going to use a fly cutter for this, which is this beautiful fly cutter I purchased recently. Look at this thing. 5 cutters. It's got its own integral R8 collet, which is great. That just means that there's less translation to happen. And I am going to just chuck this into the mill and literally peel off a few thousandths of this just to make it perfectly straight. this fly cutter. It's really nice. At the beginning of this project, I was showing you that the piece of aluminum that I had faced, and I was showing that you couldn't feel the separation between. That's from this fly cutter. It operates ideally at around 2,000 RPM, and I can take as much off as 30 thousandths at a time, but I'm not going to. This is literally just like the gingerest of cuts. Clamping in, got this going, turn this on. I can run it pretty fast on the auto feed, and it's just going to do what I need. Yep. Oh, that's gorgeous. Okay. So now I want to cut this to it's almost going to be square. Is that what's going to happen here? I have some debating to do. You know what? Okay. I'm going to show you the choice that I'm confronted with here and let you understand why I'm going to make it. The rail that I want to replicate is this rail right in here. So it's about 410 thousandths wide and about 400 thousandths tall. I know the original gun was built in millimeters, but I'm working with what I got. And you see, I don't have a lot of room to grab it. So what I think I'm going to do is I think what I'm going to do is I'm actually going to use the full body of this piece of metal to hold on to it nice and tight in the vise. Then I'm going to run a radius end mill all the way down on this side and a radius end mill. I'm going to turn it around and do a radius end mill on the other side. And then I get a perfectly centered T-fin. And then I will cut it along this axis. Actually, what I'm probably going to do is mark it roughly with marking fluid, cut it on my mini bandsaw, and then finish that last edge on the mill. That should get me exactly what I need out of this thing. So what you witnessed there is worth talking about. I engaged the auto feed on my ball end mill, and I was taking off too much material. I galled it up. I galled it up. This is what happens when you get a piece of steel too hot. The aluminum starts bonding to it. And it was a stupid move. I was trying to take off just too much material. So now I'm taking off about 30 thousandths in a pass. And I'm using the hand wheel because, frankly, you have a better feel for your material with the hand wheel. It's where you saw the smoke in the time lapse. Yes, I know that I'm cantilevered out on both sides of the vise, but I'm not that worried about it because, again, this is an aesthetic piece. It doesn't need to. It's going to be within like 2 or 3 thousandths of what I need it to be, and that's plenty because it's aesthetic. So, on to the last pass. Well, I got the first part out of the way. I am being super, super careful and cautious about this. I am moving super slowly, and it's mostly because it's a labor of love. I'm like 6 days into this build. Um, there you go. There's that little notch right there. Fits right in. Oh, so pretty. Love it. So I am now going to continue on the shaping and adjustment process to fit this in place with this guy, and then adjust it all. So yeah, it's going to be just a lot more fitment. Well, things are going really well with my build, and it is now time to add in a part that you should be able to see is missing here, the top rail. The top rail is this part right here. So you can see that it sits on top of the octagonal barrel, and it's got these 1, 2, 3 spacers. None of those spacers are uniform to each other, but that's how the drawing was. And the first order of business for doing this is for me to get these little lines. See these little lines on the top rail here? Those little lines are the first part to get right. I know enough about machining now to know that if I have a piece that's visually going to highlight any inconsistency, like little tiny shallow lines, I want to cut those first and then cut the rest of the piece to those rather than cut it perfectly to size and then somehow get those off by, literally when you're cutting lines that close, just a couple of thou can really mess you up. So cutting out these little lines first. Oh yeah, I realize I'm pointing this. Yeah, it's not a gun. See, it's just a casting. All right, so that's the next step. Now I've made some drawings that the lines are 33 thousandths apart with a 125 thou gap in the center, and there's 4 of them on either side. Here is all of my notes about the top rail. I've started putting in numbers on my drawings rather than tons of arrows with measurements written in. I love arrows with measurements written in, to be sure, like I've got here. But isn't this funny that you can see that like the 3 gaps aren't the same, they're not equivalent to each other, and neither are the screw placements? It's funny. Lots of little details like this. But these little lines, that's the next business. So I cut a test piece. Actually, it looks like, wait, there it is. I cut a test piece. There we go. And I was pleased with the depth of those lines and the width of them. And I'm doing that using this little Dremel diamond cutter. I didn't want to use a Dremel emery blade because they wear down. I needed it to maintain its exact circumference. So I'm starting to cut the first of 8 lines here. And I'm going to be using my quill feed. As you can see, I'm 630 thousandths from the center. That gives me a gap of roughly 125 thou. I'll do the same and then move 33 thousandths for the other 3 lines on this side. right, so here you can see my quartet of lines, or octet, I guess. And now that I've got those cut out and I'm happy with how they look, I may have to still clean these up with a fine razor file, which I can totally do. These are the two marks, which are almost identical, but not quite. I'm going to cut this bar down to, and then I'm going to start to shape its trapezoidal cutout to fit the top of the barrel. Ladies and gentlemen, I now have completed this chamfer cut, which fits this barrel beautifully. Look at that. Oh, I am super pleased with that. That is not an easy cut to get right. I will tell you that you just got to creep up on it. I got really, really close, and then I just started pulling off 5 thou at a time, and like, yeah, it gives me a give or take, and with the paint, that'll finally take it that last bit. Okay, so now, yeah, I've got to, right, so this is the front. I'm not going to worry about shaping the back to fitment just yet. What I'm going to worry about, wait a second. Anyway, what I'm going to worry about are the slots that come out of here and the chamfer on the two sides. That's the last bit that I have to complete to finish this top rail.
That is a great view into the depth and almost tedious and exhausting level of problem solving that this project required. And let me just state right now, I am sorry that I did not build the cylinder on camera. I will admit to you that the weekend that I did this, I was simply self-soothing. I didn't realize I was going to end up completing the whole build. I thought, I'm just going to make this cylinder because that's how I want to deal with this world right now. And then I was off to the races. And again, as you just saw in the video, it's not just a barrel and a cylinder. There's a top rail, there's a front sight, there's marks on the top rail, there's contours that have to be matched. The laser tube, which has to be totally hollow for weight and because it houses an actual laser, which meant that I had to also accommodate wiring coming through this hinge. See, every piece that I machined for this, I had to be thinking forward to what that piece would need to do later on in the gun. This hinge had to accommodate that latching mechanism working every single time. Its robustness was super required. I could go on for a long time, but this is exactly the kind of stuff that you're going to see covered in the next video.
Thanks for watching that video. If there's a video equivalent of the Clean Plate Club, you're a member. If you want to support us, one of the best ways you can do it is going to our merch store and purchasing one of our beautiful new posters. This is my hand-drawn sketch of my 2 toolboxes that I used when I was an active model maker at Industrial Light and Magic in the late 90s and the early aughts. There's also on the far left side of the poster a list of all of the tools I had in these toolboxes, and I used them daily for almost a decade. Again, you can get your own version of this printed on a beautiful cardstock by following the links below.